Okay, let's look at some other terminologies associated with set theory. The first one we want to consider is universal set. The universal set is the set that contains all the elements being discussed in a particular problem. It is represented by this big U or the symbol this. So for instance, if we are talking about sets of integers, then the set U contains all the integers, and so U will have the elements 1, 2, 3, 4, 5, 6 to infinity. If the universal set being considered is a set of students in a school, then the universal set will contain all the students. Another term that is of importance is the complement of a set. When we have a complement of a set, say set Q, then it is a set of all the elements in the universal set U which are not present in set Q, and so it is denoted by Q with this apostrophe like sign. So for example, if you have a set U, the universal set contains 1, 2, 3, 4 and 5. 3 and 4. And then Q contains 1 and 3, then Q complement is 2 and 4. Why? Because we are looking at all the elements in the universal set that is not present in the set Q. When we look at the universal set, we see that 2 and 4 are not present in set Q, so the Q complement becomes 2 and 4. This is an important concept to keep in mind. Another one is the example here. We have set A, which has elements 1, 3, 5 and 9, and then set B, which has 2, 4, 5 and 9. Let's assume they are all subsets of the universal set here. Then the complement of A will be 2, 4, 7 and 8. The reason is that when we look at the universal set here, we find 1 in it, we find 3 in it, we find 5 and then 9. However, 2, 4, 7 and 9 and 8 are not present in set A, so those elements becomes the complement of set A. When we consider set B as well, we see that it has element 2, 4, 5 and 9. We compare this to the universal set. What elements are in the universal set but are not here? It is 1, 3, 8 and then 7. So the universal set has these elements which B does not have. So the B complements are the elements in the universal set that is not present in B. So 1, 3, 7 and 8 becomes the complement of set B. Alright, with this in mind, we can take the analogy further. If we have A complement to be 2, 4, 7 and 8, and then B complement to be 1, 3, 5, 1, 3, 7 and 8, then A complement intersection B complements are 7 and 8, because when we look at their complements, we see that they both have 7 and then 8. So A complement intersection B complements is 7 and then 8. With this in mind, we can set the tone to look at Venn diagrams. That is what we'll consider in the next video. Please make sure you look at the earlier videos to brush off on the concept we've considered earlier. Make sure you like, subscribe to the channel, and also comment if the need be. Thank you. Let's go to Venn diagram next.